All right, let's get started. First up, thanks for joining in for this session. And before we get going, a few things. How many of you have at least, tried to deploy a web application or just developed a web page or two? You do not need to be an expert, but at least you're in the right session then to further appreciate what goes on over the next 25, 30 minutes. Next, how many of you have at least spoken to via prompt to some LLM or the other, made some call and got back something? So good. These are the only two prerequisites to better understand what's going on, right? Third question that I have is, how many of you have tried to understand or have read about that, hey, it's possible to, maybe run these LLMs right within the browser itself? Anyone? Felt the need for it? No? Yes? Okay, doesn't matter. So that's not too mandatory, but we'll get going. So the topic that we have today is Chrome built-in AI, features right within your browser. But we'll sort of keep expanding on that, what it precisely means. We'll see several examples, and the agenda looks something like this, which is we'll just focus first on why AI on the device. And when we say device, what we are trying to say is literally the large language model itself, right, is brought to the device or wherever you're trying to run. This could be your laptop and maybe in the future, maybe even smaller, less capability like devices, right? So we'll just take a look first at what are the points, and some of these points are similar, like if you're trying to run applications offline or locally, the same benefits apply, but there are some very specific benefits that AI on the device brings. We'll talk about that. Then we'll sort of start diving into what does all this Chrome, built-in AI, what really does it mean through examples and what it's trying to do, right? And obviously we'll have a few demos that actually demonstrate what is available today in Chrome built-in AI, is what you can do within the browser itself. These points are all okay, right? But really what I want you to go back with are a couple of points which you see over here. One is you'll at least get a good sense of what it means to get started with built-in AI. So that's one. And obviously, like I mentioned earlier, if you've been dealing with web applications or developing them or are currently maintaining it, how do you realistically bring some AI features into your web applications? And we'll see some of these examples where it'll be a bit interactive. I'll show you a web app and I'll just sort of understand from you how you would potentially use AI features. So one is to just say, we need AI, we need these LLMs, etc. The other is to actually look at your apps, see what value AI can actually provide. So we'll try and hopefully get a sense of these two things at the end of it. Now, just take a look at this picture for a moment, right? And earlier I was mentioning to you whether you have invoked an LLM or worked with an LLM, etc., right? Now, focus first on the right-hand side, which you see over there, which is, that's our browser. We've got some kind of an application that's running inside of that. And what you find is a call that's going over the net. You've got some AI model in the cloud. It could be any of those Gemini ones or even other third-party, models, obviously running on a highly performant infrastructure that's needed to sort of not just train, but eventually even host and infer out of it. Is this picture clear to most folks, right? That today, if you are to actually embed AI or make calls to it, your thought process typically is that, yes, I'll need to do something on the server side, whether it's standard models off the shelf or any tuning or whatever it may be, I'll need to host it, I'll need to give an endpoint, and then I'll sort of integrate it into my web application. So this is nothing wrong with it. This is the picture most of us think, right? Now, obviously, this is not the topic that we are going to be discussing today. We're going to be taking it much more towards that side, right? So just focus there first, which is the web browser. Now, what if it becomes something of this sort? Okay, which is that even within the browser, and some of you might have worked with it, there's already been some sort of movement towards that, can we run these things more locally, right? And for example, whether you've got or let's say on this laptop as an example, is it a CPU or GPU, any of the other processors that are out there? But can I run all of these things inside the browser itself? And obviously, there are many frameworks that are out there that let you do that. You can literally even download a model that gets downloaded into your browser, and you can do your invocations of it, right? So these things are also going on at the same time, right? However, before we go into further what's Chrome AI, just let's revisit that first point, right? That, okay, if I go back for a moment, why are we trying to do this in the first place, right? Do we really need it? Weren't we happy with this model right now? That, hey, everything is fine. You got the best of breed models that are out here. You can invoke them. Why do you want to simply complicate everyone's life and say, no, 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 get it towards here? So that brings us to this point, right? That why does it matter on the device itself? And most of these points actually are known to most of us. Any thoughts? Why would you want to run this on a device? Data protection, privacy, data doesn't go up, it doesn't go over the network, everything is happening locally, right? So let's look at some of those points, right? So enhanced privacy, right? Everything is right here in case you wanted to do something and not send your data. For example, what if I could do something like look at my Gmail, summarize today's emails, and tell me what I have to do, but right within the browser itself. I don't want to send all that up and all of that stuff. So privacy. Other points, performance, right? You're just ignoring that whole call that goes across. And again, this is nothing specific to like AI on a device. I mean, these are typically things that you get from local processing. Offline availability, cost, right? This can be a big thing. Nothing is free on the server. While it may give you a set of free tokens, etc., it's not really free. After a while, you got to pay for all of that stuff. And zero install as well as reach and scale of the web. Typical benefits that you get from doing AI on the device. So far with me on this? However, the fun starts now. How many websites do you visit on an average? 5, 10? Let's put it, like 10. 10 could be. There's nothing right or wrong answer, but let's say you've got several sites that you visit daily. Now, what if you start saying that each of these sites is going to provide an LLM of its own because, that's the selling value of that site. Now imagine what happens again from a model delivery perspective. For the end user, you'll be visiting each of these sites. These sites are not going to be sharing their LLMs in any case, right? So for each of these things, you'll have to download the LLMs just in order to make it work on your local device, right? So as a result of which, you see what you're seeing on the right-hand side. These LLMs are not small. I mean, they are distilled, of course, they try to make it as small as possible, but not yet small. Now, if you visit so many sites where everyone is distributing its own LLMs, you can imagine longer downloads, you can imagine the experience that will suffer, of course, data usage, and just think about the storage. What are you trying to say over here? I need to have how many gigabytes? I'm visiting 100 sites. Each one wants to give me their LLM, which needs to be first downloaded into the browser. So this approach, right, where though it is feasible to get those LLMs into your browser, not feasible, though it's possible, it may not be practically feasible to do this. Now imagine for a moment, what if these LLMs keep changing? What, every morning you're going to wait for a few hours to get all the sites updated with the LLM so that it can run locally? May not cut it, right? But this problem is only, I'm saying, from an end user perspective. Imagine the other side. You have a website, you have your own LLM, right? And imagine this becomes terribly or too popular. As a result of which, you've got possibly hundreds and thousands of users, right? Who are going to be visiting your site and downloading. How many of you have burnt a hole in the pocket, wallet, credit card, whatever you call it, due to egress costs in the cloud and things like that, right? So obviously what we are talking about is high serving costs. If you've got a heavily trafficked site where everyone starts pulling out your model, you're going to be looking at just high cost to even serve this. I have not yet even gone into anything around experience. What if you have to update these models regularly? what that experience would be for the end user. Every morning you can imagine when they hit your site, the first thing they'll have to do is wait for a few minutes for the model to download or get updated before that, right? So while these things are practically possible, it doesn't help from an experience point of view, right? As a result of this, we are going towards something of this sort. And this sort of is leading me into this Chrome built-in AI sort of an experience, right? Where we are saying, let these sites do what they want, right? But the model that we are talking about is not going to be downloaded every time you visit a site or first time or it gets updated, etc. The model is in the browser itself. So Gemini Nano model will be shipped within the browser itself to avoid all the previous things that we are talking about. Now, this should bring up a first question. How does Gemini Nano really solve anything specifically for these websites? They are looking for that, can the model do this? Only then does it make sense, right, for these folks to say, okay, download Chrome browser, it has Gemini Nano model, and it should do it. So we'll lead slowly into this discussion, but this is the premise out here. You download your browser or you update your browser normally, it's taken care of, the model updates. Similarly, I've just shown you one glimpse of it when you actually come to this particular point, right? Or let me just step back a bit first. That so far clear what's going on with Chrome built-in AI, that the AI or the model is within the browser itself, updated with the browser. You might even ask that, would it know what kind of hardware I may have, CPU, GPU, NPU? Would it know how best to run it? Yes, even all of those things at runtime will be taken care of. But the question comes now, right, that when Chrome engineers went out to build this whole thing, right, how would they know what should we do? We can't just ship the Gemini Nano model as is and say, yeah, let people figure out how good the prompt might do or not, right? So they had to grapple with this problem here. I'm just giving you a little bit of background so you understand how it's all coming about, what it may eventually have. That's why I'm stressing on this. So if you look at it, right, should they focus on the model quality, right? Should they focus on performance? Or should they focus on devices reach? Because at the end of the day, the web is open to all, right? We have no idea when someone is just launching their browser and accessing a website, right? Typically, what are the capabilities of the device? So should we reach more devices? But if we reach more devices, possibly a little bit of compromise to be done on the quality, possibly on performance. Because if devices are not having too much power, I may need to make my model smaller. If I make my model smaller, I might hit a bit of the quality, right? So you have that typically, right? Choose 2 out of 3, or should we play some games somewhere so that, it meets. So now imagine for a moment, right? If you were on the Chrome engineering team and you were told, yeah, this is the model, it's there, where will you focus? How will you even arrive at a model that can be shipped into the browser? What kind of problems will it solve? Not problems, what kind of use cases should it support? So that's where they went on actually a sprint with several folks from partners, which were like, what would be the use cases that we need to address? So if those use cases are typically handled as a first version, then maybe we ship a model. So if you see here, a little bit of a generalized thing is done that, okay, it'll meet a bit of performance, it'll meet a bit of reachability, it'll meet a bit of quality, but it should address certain use cases, and that's where the initial decisions were. So that brings me to these typical use cases, which you all know about as such, right? You've always, not always, but you sometimes talked to some of these LLMs and said, maybe do a bit of summarization, maybe do a bit of extraction of certain entities, maybe semantic search, classification, sentiment analysis. So what the teams did is, if you look at these use cases, we'll pick a few as a first version. So if I go back to the previous slide, what you see as use case A, B, C, D, E, F is nothing but some use cases from here. And said, let's focus on these first. At the same time, what we should do is, which is most important, is give a simplified web API around it. Because unless you're going to be giving a simple web API around it, there's not going to be any acceptance of these use cases. So if I want to do something like a summarization, there should be a web API which is as simple as something like .summarize. Or, for example, if I'm doing a, let's say, translation, right? Or writing, rewriting, it should be just a method call and a prompt along with it, and it should do its magic, right? So that's the level of abstraction that needs to be provided. So given all of this, right, if I break down or if I go back to the previous this one screen, you might be saying, what's going on over here, right? So they took those use cases and whichever ones they wanted to actually surface in the initial version, which you can try out today, it has created web APIs around it so that you can use it straight away. Just download Chrome Canary, we'll see all of that, enable the built-in AI, and you get a bunch of APIs enabled right within your top-level objects, and you can start using it, right? Moving forward, they do have some ideas even on further fine-tuning that you could potentially do, but it's not there at the moment. But we'll see what those APIs are, and that's what I'm going to just first open them up over here. So these are the APIs that are available within the Chrome built-in model. That's there in your browser. You get high-level APIs. We'll see all of these work in action. So when it comes to, I'll come to the prompt in a moment, but summarize it, write, rewrite, language detect, translation. Prompt is a very general API that's there for still people to explore. And then if it turns into a use case, they may convert it into one of these task APIs. So you get both a general prompt API that you can try within your browser itself, as well as any of these specific APIs. We'll see examples, it should start getting clear. So, it starts to look something like this, the diagram, right? So you've got Chrome. Within Chrome, obviously you've got your model there, and these specific exploratory APIs are nothing but the prompt API. So you can just keep exploring and seeing whether it works. Task-specific are like translate, detect a language, summarize it, write, rewrite, things like that. So you've got a bunch of that. This AI runtime is completely managed by Chrome itself. So depending upon the hardware capabilities, it will execute those APIs for you, right? That brings me to the next point, which I mentioned a bit earlier, which is, there's AI everywhere. Everyone wants to use it. I don't want to keep expanding upon that. But the point is, right, you ideally see what's the problem that you're trying to solve, right? And just to sort of highlight that, and that will give you then a good picture about how you can use the APIs, is let's take an example, which you see over here. So let's talk for a few minutes about this. This is, again, a bug tracking system, a task system. You can call it whatever you want, right? So how many of you have been on the other side or the receiving side where you had a bug reported, assigned to you, and you had trouble even understanding what was the problem about, how the person wrote the title of the bug or the details of the bug or something of that sort. So again, this is a very simple thing, but it highlights a few things. The columns that I've actually highlighted, right? Think for a moment, right? What could you do? Any guesses? There are at least 4 or 5 things you as a web developer, if you have a similar system, forget these tasks or a bug tracking. For a moment, just tell me, what could you do with this? What if someone just wrote in their language, right? And now you have a problem with the language. So just think about, should you be doing all of this on the server every time? You don't even know whether you want to read or not. So what if I could literally say, if English is the thing I understand or XYZ is a language I understand, I could possibly detect locally, and I could also translate locally to get the understanding. That's one. This is a title provided by the user. How many of us have ourselves reported problems and said, let me just put this in the title and let us just figure out what it is. So assume this is a title provided by the user. You have a golden opportunity now of taking the content and generating alternate titles in a summary. So when you summarize locally, you could possibly actually give the actual title or the problem not that it's not working, right, versus what the problem is. Similarly, a summary. Instead of reading all of that stuff, what if you could first provide a summary to the user, right? Even this, the category the user selects. Sometimes in our UI, we are giving a drop-down telling the user select the category of problem. Maybe it's wrong. Maybe from that, you can detect what the actual category, the classification. Again, all of this stuff could be done within your browser there itself. The biggest fun stuff is this. I'm just going to go to a version of it that I have running here, right? Same one. Search, right? A typical one, right? You put something and it filters. Now you see that first line, headphones, correct? So if I put headphones, it's doing something. What if I just put the word earphones? Am I even seeing it properly? Right? One, two, and phones. Now you see that? Is it really different, headphones and earphones? You've all been saying we need semantic search. It should be able to understand, right? So what if you actually converted that not just into a brute force kind of a search into your list, but saying this is similar to this. So I should be opening up or showing you the, bugs that are matching to that. So imagine all of this stuff you could potentially do. Don't make a vector call to be made somewhere else, right? That's just going to destroy the experience. Not that it's not possible, right? So I'm just leading into the different APIs that will come up. So that's why I just wanted to show this so that you see potential ways. That second point which I was mentioning, what if you could just go back from this session, relook at your existing web apps and see where you could start integrating some of these AI features. Having said that, let's see how we can get started. Enough talk, let's see some demos now. Again, all of this is there at that URL, and it gives you how do you get started. But few things, join the early preview program. That doesn't make you enabled, it's just that you'll get updates because it's a bit of leading edge, so it could be changing on a very frequent basis. But the second thing is important, right? I mean, you might get disappointed depending upon some of the hardware requirements that are currently there to run Chrome built-in API. So if I just go to that, you see this is again taken from the documentation itself. Depending upon the operating system, you do have certain requirements that are there right now. To at least see it in preview. Later on, as the model goes towards a general thing, it could completely change. But currently, if you want to try out, these are some of the restrictions or requirements that are there from a hardware perspective. So if second is fine, all you need to do is download Chrome Canary. I've spent hours thinking why a feature is not working, and I found I was using the normal Chrome. I had not switched to the Chrome Canary. So Chrome Canary is where all the things are happening right now, including Chrome built-in AI. So you'll need to download that, and then you'll see things will work. Obviously, a few flags to be enabled. And the most important thing, which is right now the experience is that you need to at least invoke one call in order to let the initiate the download of the Gemini model. So that's the very quick call that I've shown over here. So again, these few things are more than enough for you to actually get started with it. So obviously the hardware requirements, a few Chrome flags, as I said, nothing major. You just have to, like for example, if I go to these settings here, so this is in my Chrome Canary. As you can see, those APIs that I was talking about, the prompt API, the summarization API, it's the enabled, I've just made it enabled right now, the writer API, rewriter APIs, translation, so on, right? So once you get Chrome Canary, you get these flags, you just need to enable it, and you should be good to go. What we're going to be seeing next, obviously, are several demos, but you can take this URL. This has all the projects also on GitHub. So if you've got Chrome Canary, you want to directly try out these projects that I'll be showing, they are all available over here. So let's jump into the demos now. So first step, as I told you, is an experimental API, right? The prompt API, where you can literally say, I've got a prompt. I just want to hit the Gemini model, see what kind of responses it comes back with. I'm just still trying to discover the use cases or where I'll be exactly using it. So you can use the prompt API. And if you can see, right, it's the high-level API that's created is fairly simple. So at the top, you're just creating the model itself. You can give a system instruction if you want in order to lead it towards where you want it to answer. And obviously, this is a function, but whatever be the text, right? All you're doing is prompting the model. So dot prompt. That's all there is to it, really, in this scenario, where if you want to try out something, it's all about this. So now I'll just switch to the demos also simultaneously, so you can start seeing both the reality also. So you might say, is it running fast? Is it like, very zippy? Answer is no. So I'm going to just show you so that you're also sort of mentally tuned that these things are still like a work in progress. So first up, obviously, let me go. This was the stuff that I was telling you. Let's go here, right? What you find here is, I want to take each of these, what is that, review text, sample review text, and I just wanted to do some kind of a sentiment analysis on it. So all I'm saying is, just review this for the text given and see what it comes up with, right? Obviously, it's entirely up to you what prompt you give, and I've just kept even that inspect thing open, so we can, it just goes through one by one. And you can see the speed at which things may happen, right? So it's taking each one. It's hitting a local model, by the way. By the way, I don't need a net or anything like that to run all of these things. So it's just taking it one by one. And it also shows you how good or really how bad I am at web programming. I just take all of it one by one, make a call. And then I want to populate the sentiment column with it, right? Obviously, I have not formatted it. That's also to tell you, you can demand certain formats, like a markdown or whatever it might be. But you can see, I've just tried to say, tell me what's positive, tell me what's negative. And it's done an analysis of this. You can do it all within the browser itself. And the call, as I mentioned to you, is as straightforward as what you're seeing, right? So see, you're a reviewer of comments, just analyze and identify, and just give the text, right? So the prompt API is experimental. The next one, if you see, is the language detection and translation. You might be familiar anyway with the translation API and things like that, but this is all within the browser itself, right? So what you find is a detection, like I showed you the previous bugs list, right? Where they could be in different languages. So first thing you want to do is at least detect the language. Because to translate, as you can see, I need to know what's the source. I need to know, of course it can try to detect, but it's better if you precisely give it values. So if you see, it's again very straightforward. The language detector create, you can detect a language. Similarly here, translation, you create the translator and do a dot translate. The calls are as straightforward as this. And as an example here, you can see something this. There are 3 entries right out here, and I'm just doing first a detection on it locally. So this just tells you what language it detected for each one of those. And then obviously I'm just hitting this to translate the thing. So this is, again, if you go back to this example which I was talking about, right? You could do it within the browser itself. Either you understand or say, no, please translate it for me. You could have detected. Sorry? All local. We have to write what? This is a simple one single web page. So, no, this is just showing you the example, but the code which you see, for example, this one, right, is as straightforward as see the source. There are these calls here. I'm creating a model, and then I'm doing an analyze sentiment, the method which is there, which calls the prompt method. It's all locally running within this. So those API methods which I showed you, they are integrated into the web page. Yeah. So where were we? So again, this particular thing which I showed you, you could have actually done it in the browser itself, detect the language, as well as translate. The next one, which is summarizer. Again, as you can see, it lets you summarize in different ways. So when you create a summarizer object, you can do either a TLDR or a teaser or a headline or whatever it is. And depending upon that, you just have a simple .summarize call. And if you want to see an example, I've just shown one here, which is, that's the text, and I want to, just summarize in different formats. So again, summarizing now, it will give you either a TLDR. Again, you can say long, short, or whichever way that you want to. So there you go, right? So this is again completely local. And again, a better example of this, which I wanted to show was, these, APIs are also available for your Chrome browser extensions. So if any of you are writing Chrome browser extensions, these APIs are available. So as an example, say this is a website that I am at, and I've written a Chrome extension which can, like, for example, let's take this and right-click, and you see this summarize. So this is an extension I wrote, which is on a site panel, comes up in the context, and it can summarize whatever you selected completely locally. So which you see there, it's summarizing whichever part of the code that you want to, and gives you that stuff. A similar summarization, let me go to that example. Now think about this, right? See what's happening. Or this was run, so I'm actually just doing a refresh here, and you see I'm summarizing on the fly a particular, let's say, what could be the summary of this. Or this title is actually not the one here, but it's based on the issue description. So you see here, it says site is slow. Site is slow means what? It's actually something else. It's actually done a summary from the content, right? So I'm just showing you all of this running locally without going anything outside, but just how you could even improve your existing web applications. Summarizer tooltip, that's precisely what I showed you right now. And the code was as simple as this. As long as you identify which area, the calls are just create the model and prompt it. That's it. And the prompt could be like summarize this text for me. That's all. And then you show the tooltip. And finally, right, I mean, of course, I have not shown one of them. That's a demo that's over here. Let me just, there's a reader and a writer thing. So you could literally say any prompt, and then there's a writer API that should ideally generate things for you. So there's a streaming API also supported by the Chrome built-in API. Once you're done with this, you can say, I want to rewrite it with whatever be the thing, or I want to, manage my length accordingly. It should be short or, longer, or whichever way, right? So reader, writer APIs are also available within Chrome built-in. So finally, what I have is a quick, in case you want all the documentation that's there, but there's also a challenge going on with some quite big prizes. In case you are able to come up with an interesting use case that could be potentially something with the prompt API that you are trying out, but then it could be an first class API that they could eventually convert into. That's all I had from my side. Thank you.